Hello, PreCalc. This is Thursday's lesson after the test, so we're going to start something new. So, I hope you did well, but good or bad, we're on to something new. And you can redeem yourself, or you can just keep laying the good ground. So let's see what this good ground is leading us to. Exponential functions. All right, so what is an exponential function? It's a function where the variable, like the x, is in the exponent. This is going to lead us to logarithms, but we have to stay here for a little bit. Variable is in the exponent. So the most basic one is y equals 2 to the x, and you can see the variable x is up in the exponent. So I'm going to graph that function. I'm going to use a sissy chart probably a couple times, but not very often, because I want you to be able to graph these without a sissy chart. So charts like this are for sissies. So I'll do like 2, 1, 0, -1, -2. That's usually enough to get the chart that you need. So when I put 2, and so the graph y is 2 to the x. So when I put 2 in for x, I get 2. Zoom in a little bit. So I have y equals 2 to the x. So when I put a 2 in for x, I get 2 to the 2. When I get 1 in, I get 2 to the 1. 2 to the 0, oh math student, is 1. Anything to the 0 is 1. Moving down, -1. What is 2 to the -1? I need someone's thought cloud. Alright, so 2 to the -1, if you recall from missing, it's as if this is 2 over 1, and it causes this to invert. So we have 1 over 2, and now it is written to the 1. So when you have -1 as an exponent to 2, it's a 1/2. So what does this one mean? All right, I will gather somebody's thought cloud. How about I grab Maggie's? All right, Maggie, what is -2 to the -2? I'm sorry, this is +2. So my function is 2 to the x. So I have a +2 raised to a -2. So it works similarly. All right, and Maggie, you've got it right. When this negative will invert this, then the 2 will run along with the 2, and it becomes 1 to the 4th. I mean 1 over 4. 1 to the 4th. 1/4. All right, so I better graph this while I can still think. All right, so this one is 2 over 4 up. This one is 1 over 2 up. 0, 1. -1, 1/2. -2, 1/4. All right, so you should remember this. I think you've had this part. All right, so wonder what it would look like if it was y equals 3 to the x. So I'm going to put that on the same graph. So I'm going to establish another chart, another old sissy chart with the same numbers: 2, 1, 0, -1, -2. And x and y equals 3 to the x this time. So when I put in a 2, I get 3 squared or 9. So I'll graph it 2, 9. All right, up here in my word, that's 2, 9. And 1 to the 3rd, 3 to the 1 is 3. 1, 3. 3 to the 0 is 1, so this point again. -1 becomes 1/3, and -2 becomes 1/9. So, all right, All right, so looking at the relationship here, this is y equals 2 to the x. This is y equals 3 to the x. And if we were going to do y equals 4 to the x, it would go like this, and y equals 5 to the x, and y equals 6 to the x, and so on. So it always goes through this one point, because whenever you raise a number to 0, you're going to get 1. So this point is on every exponential, and notice the tails are pretty much alike. I know when you have 3 to the x went lower than 2 to the x, but if you were just doing a quick sketch, it wouldn't matter as long as you had what I call the tail here, and then it goes zinging up. So what I expect of you, suppose I asked you out of the blue to graph y equals 2 to the x. I would not ask you to do a sissy chart beyond this. I would like you to do, when x is 1, what is y? That's not much of a chart, but that's all I want you to do. Because first of all, you know this point is on every exponential. So now I go 1, 2 gives me 1 point. I know the tail looks pretty much the same for all of them, and then it goes zinging up. So look how quickly I got that, knowing the basic pattern ahead of time for exponentials. So let's do another one. Let's do y equals 5 to the x. Quick method. So the chart will only have 1, and when I put a 1 in, y equals 5 to the 1, which is 5. So I go over 1 and up 5. And I know this point is on it. I know the tail is over here, and it goes zinging up. So, and if I did one more, y equals 10 to the x. So I have y equals 10 to the x. This point is on it. When x is 1, y is 10. Tail zinging up. All right. So you must be able to graph these exponentials upon command. All right. So now we'll expand that discussion a little bit. What about y equals 1/2 to the x? Y equals 1/2 to the x is going to look a little different than y equals 2 to the x did. So again, we'll use a sissy chart. 2, 1, 0, -1, -2 will give us the good idea. So what's 1/2 raised to the 2? 1/4. What's 1/2 raised to the 1? 1/2. Anything raised to the 0 is 1. This time, when I raise 1/2, someone's thought cloud. All right, Dan, you're up. 1/2 to the -1. So that negative sign is still going to invert this. So 1 over 2 becomes 2 over 1. And once I do the inversion, this is now positive. So I get 2 over 1 to the 1, which is just 2. Thank you, Dan. All right. Okay, Dan, try it again. 1/2 to the -2 this time. All right, speak clearly. Got it. Get 2 over 1 squared, 4. Good job. All right, let's graph it. And when we do that, we get 2 over, 1/4 up, 1 over, 1/2 up, 0, 1, -1, 2, -2, 4. So what has happened in our exponential graphing world? We still have this one, but the tail is on this side and it goes zinging up on this side. So that will always be true when this is a fraction. So it won't surprise you that I ask you to do quickly y equals 1/3 to the x. And that will include this point, the tail here. This time when I put 1/3 to the -1, I'm going to get 3. So it's going to go the tail, and then it's going to zing up closer to that y-axis. All right. So now you see the difference between y equals 2 to the x and y equals 1/2 to the x. There's another way of writing 1/2 to the x I want you to be aware of. It can be written as positive 2 to the -1. So that's what 1/2 equals to the x. So then I can improve on that by multiplying these together. 2 to the -x. I just want you to be aware sometimes they'll throw that at you, and I just don't want that to trip you up. That means this, y equals 1/2 to the x, because that negative exponent will flip the 2, and it'll get you to this. So be aware when y equals, say, 4 to the x and y equals 1/4 to the x, be aware that the tail is on the right for this one, and it goes zinging up, where this one, the tail for this one, the tail is on the left. This is y equals 4 to the x. For this one, the tail is on the right. What I call the tail, it's tailing off. And it goes zinging off to the left. So be aware of that and be able to remember that for tomorrow. All right, we'll end with looking at y equals 2 to the x and y equals 2 to the -x, which we just covered. And I'm going to add something to it. Y equals 2 to the x. Y equals -2 to the x. Two to the -x, I mean. This is the 0.01. Now I can grab two more that show up. Y equals -2 to the x. When the minus is outside of this one, it will invert everything over the x-axis. So whatever was positive will become negative. So I'm going to take this one and I'm going to flip it along this line. So like if I was going to make this in charcoal and fold it on this line, it would imprint like this below. So this negative sign in front will invert across the x-axis. So do you see, this is a inversion of that. We'll say flip across the x-axis. I'm not sure what a good word is for that. Flip across the x-axis, and I know, we'll use the math word. Reflex. Reflex across the x-axis. All right. So, and the fourth one, y equals -2 to the -x. So now we've already flipped it across the x-axis, but this flips it across the y-axis. So if we take this and flip it across this axis, this comes over here, and this part goes over there. So this one is y equals -2 to the -x, and this one is y equals -2 to the x. So take a look at that. All right, let's close down our discussion on exponentials for now, and we'll be pulling that out of our magic hat and working with those kind of problems in the morning. So till then, over and out.